Hi everyone, and welcome to another episode of Global AI Notes. Today we're going to discuss more about how we can do data analysis with Codespaces, Codes, and Jupyter notebooks. So stay tuned and learn more about that. So we want to learn more about GitHub Codespaces and data analysis, and therefore we invited Nitya. Hi Nitya.
Hi, Sammy. How are you doing?
I'm doing well. Glad to have you in the show today. Nitya, can you please?
I'm very glad to be here. I'm in New York, by the way, and it's absolutely cold and fall, so I'm super happy to be here online.
Well, for me, it's the other way around. I'm in Nairobi and it's quite warm here.
No kidding. Oh, we need to talk about that. Okay, great. I did not know that.
Nitya, please, who are you for the ones who do not know you?
Oh, that's such a loaded question. So, my name is Nitya Narasimhan. I'm a senior cloud advocate on the AI advocacy team at Microsoft. And in the past few years, prior to this, I was on the JavaScript advocacy team, the mobile advocacy team, and I've also got a background in research. But in the context of this talk, I'm actually going to come in with three hats. One, I'm the parent of a high schooler who wants to do competitive programming. Everyone wants Python. The other is I'm an AI advocate, and we all need to know more about Python. And the third is, and this is actually my kind of like reason for being here, is that I'm an app developer first and foremost. And many times we're just being swamped by so many shiny new things. So we're like, how do we get productive fast? So those are the three roles I'm bringing to the table.
Okay. If it's quite a big sandwich of different things that you've been doing. But yeah, as I said, I'm really looking forward to, of course, for people who've been doing data analysis, they've been using Jupyter notebooks. But now the combination with the GitHub Codespaces, personally, I've tried it out and played a little bit with it, but I'm really looking forward to learn more about that. So with that, I'm going to give you the platform. If you can share your screen.
Sounds good. I think I should be sharing it. Awesome.
Yeah, there it is.
All right. Okay, so let me quickly just make sure that I can switch between screens. Yep, I think we're good. So I'm going to take it away. Hi, everyone. So today I want to talk to you about how you can simplify data analysis, but with GitHub Codespaces, Jupyter Notebooks, and OpenAI. And this is a version of a talk that I just recently gave at the PyData NYC conference, but it's also a project that's close to my heart. And because of this, there's a twist. I'm not coming in here as somebody who knows Python or is a data science expert. I'm coming in here as somebody who's an app developer who needs to use these tools. And I'm like, how do I get productive fast? So to set the stage, right, I've kind of been running into this problem. And this is my story. I really want to walk you through this story of my life right now. Think of this, right? This is happening to all of us. I'm an app developer. I'm not a Python expert. I'm not a data science expert. It's going to take you about 5 to 10 years to get the level of intuition that most data science experts need. But pretty much all of us need to like get skilled on AI and Python really quickly. So my question is, how do I learn enough to tackle specific goals for my apps, right? So I want to give you a few examples of the things that motivate me. First and foremost, I'm the mom of a high schooler. And did you know that they have competitive programming in high schools? There's actually something called the USA Computing Olympiad. And until last year, in fact, you could always program in C, C++, Java, and Python. But until last year, nobody wanted to work in Python because Python was not competitive. Why am I telling you this? It turns out that there's a huge gap in solutions. So if you want to learn how to solve competitive programming problems, you don't have many resources. So there was a gap, and we wanted to fill that. The other kind of example is you'll see that little colorful chart there. As a web developer, as an app developer, I built a lot of websites, and we know that accessibility compliance is a problem. So did you know that you can run accessibility tests on the site to get a report that tells you what the issues are? But here is the problem. The average page has 1,200 plus elements. And to test for accessibility, there are about 100 rules. And each rule has about 3 to 4 checks that you need to do to validate if the rule was passing or failing, right? So you can see this is explosion of data. And as an app developer, I'm like, I get all this data in my testing workflow, in my VS Code. How do I make meaningful use of it to fix the issue right now? And last but not least, we've all done this. We've all written applications which go talk to an API and bring back a whole bunch of data. This is an example of a def.to endpoint that gives you back all the data about all the articles published for the Azure publication. And I'm like, I want to be able to provide a dashboard that lets people see the big picture, right? So these are the kinds of applications that were motivating me. But I had this kind of objective, right? I don't want to boil the ocean. I'm not here to learn another language. I've been doing this. I'm a polyglot. I've been doing this for decades. And what I want to do is I want to learn enough to solve my problem. I want to be productive. So I wanted to have focused learning. I want to prioritize learning the things that help me get closer to my goal. So don't boil the ocean. Just tell me what I need to learn right now to get things done. And the second is I wanted transferable learning. What that meant is I want to be able to do this work in a way that I can then hand it off to my high schooler, or I can hand it off to a real data scientist and say, hey, I've been doing some of this work. Can you take a look at it? So how can we make this possible? And here's what happens, right? Every time you have one of these questions and you go talk to people, they're like, have you looked at Python yet? Have you looked at Python yet? So I was like, great, I need to go look at Python. But I had these three challenges. The first is the developer environment. I was actually at PyData in New York City recently, and this is still an unsolved problem in my opinion, because you walk into a session, there's a workshop, they're like, oh, please install this Python version, then install these patches, set up a virtual environment. By the time you've done all the things you need to get done to get started, one, you've lost time, and two, not everyone has the same experience. You all heard this thing, right? It works on my machine. I've heard that a lot of times. In my case, for example, I work on a Mac. My high schooler works on a Windows machine. We don't have the same experience. How do we make this easy for beginners? The second challenge is the learning process. This is something we all know. What happens is we'll be working on our code, and then we'll be like, I don't know what this is. Let me go Google that. 3 hours later, you're like, what was I doing? I was just sitting on the web, like in rabbit holes, like trying to chase stuff down, and I forgot what I started searching for. We don't want that. I want to be in my state of flow until I solve the problem. And last but not least, and this is actually the toughest one, we all have knowledge gaps. I don't have 20 years or 10 years of experience in data science. I'm starting to pick it up to solve real problems. And the thing is, data science is all about intuition. And I don't even know what I don't know. If I knew what I didn't know, I could go search for it, but I don't. I have to like pick this up. So what if I miss something because I don't have the level of knowledge other people do? So I wanted to solve these problems. So what I want to cover today is really these 4 tools, right? First is for transferable learning. All of you who are familiar with Jupyter notebooks or familiar with data science or familiar with Python, you're like, oh, this is no-brainer. But I want to also talk to all of you who are beginners who want to come to the Python space to try this out. Jupyter notebooks provide transferable learning because they're like a notebook where you can put both the content and the code together. So people can literally read the story of what you did, capture the history of what you did, and it's an environment that you can run the code in so you can reproduce it. Next, I want to talk about a consistent development environment with GitHub Codespaces. We'll look at that in a second. Third, I want to talk about how we can get focused learning by using GitHub Copilot. And last but not least, I want to briefly introduce something which I feel is really awesome. It's an open source project called Microsoft Lida. And what it does is it's kind of the tool that I look at to help me improve my own intuition about data visualization. So if you want to follow along, go check out ak.ms/pydata-workshop-2023. I have some of this there. I'm going to walk through these in slides and switch back and forth to look at some code when we can. What you need is just a GitHub account, fork the project, and we'll launch Codespaces in it. Codespaces has a free quota, so you should be able to launch stuff without kind of affecting your quota. Bring your own data set. I have a couple of Kaggle data sets, but you could bring your own data set and try it out on your own later. If you can, activate Copilot. Now, Copilot requires a paid subscription. There is a free trial available, but it's okay if you can't do it. I'm going to show you what it can do, and then maybe if you're interested, you can go try it out. And last but not least, you need an OpenAI API key if you want to try out some of these ideas. But again, I'm going to show you what you can do, and then you can try it out later. So part 1, we're going to solve that very first problem, right? I'm like, I want to be able to go up to a problem and not have to deal with setting up a development environment. I just want to get productive fast. Can I get a reproducible development environment with GitHub Codespaces and Jupyter Notebooks? So what I want you to do is go ahead and fork that repo that I just gave you a link to and launch Codespaces. How do you do that? So here is what that looks like when launched, but let's actually try to launch one ourselves. So I have that repo right here. I'm not going to fork it because this is already mine. But what I'll do is I have a running code space, but I'm going to start a new one. What you're literally going to do is just launch a code space. And if you watch this, you will see that it actually sets up a container for you, install some of your dependencies, and within seconds, I have VS Code running in the browser. That's it. It set up everything I wanted. In seconds, it has the Python environment I want. And wait, it gets better. There are notebooks in here. I can actually open one of these, go in here. Am I actually able to see this? Select a kernel. And I'm going to say it has to finish installing some stuff. But okay, it's picked the Python 3.10 kernel. And I'm like, okay, let's go ahead and see if this works. I should be able to run it. And it should. Let me close all these. And it should be able to run these for me. Well, still connecting. I need to wait a little. Oh, sorry. It's still installing some of these. So we're going to wait until it's done. But once it's done, you'll see that it is actually connected to a Jupyter kernel and it's executing it. I had my environment set up. I'm running my notebooks. I didn't even have to do anything and it's consistent, right? So the very first thing I kind of wanted to get to is that I'm able to solve the development environment problem by using GitHub Codespaces. But we're going to look at what that is under the covers. You saw that it launched a Visual Studio IDE. You saw that we ran a default notebook. I just wanted to give you a sense of what it can do in seconds, right? And we were able to go and do something really trivial. And it wasn't a very major thing. It's actually the default notebook that comes with the Codespaces Jupyter template. But my point is, I was able to get productive really fast. How did that work? So for those of you who are not familiar with GitHub Codespaces, this is what it looks like under the hood. Think of Codespaces as that green container. It's literally a development container that runs in a virtual machine. You can see that in blue in the Azure cloud. That means you've got a dedicated machine that has the environment you want running in the cloud that you can attach to from everywhere. And that's the nice thing, is that because it's GitHub Codespaces, it actually has set you up to use one of multiple supported editors. You can use VS Code on the desktop. You can use VS Code on the browser. You can even use JetBrains or a command line. And if you go look at that little box in the left corner, if you actually go into the Codespaces settings, and I'm going to show you if I can, give me a second. So right here, where was that? Okay, here. This is my Codespaces settings. If you go to github.com/settings/Codespaces, there's a place where you can set your editor preference. And if you're a person who's a data scientist all the time, set it up to be Jupyter Lab. No harm done. But what it's doing under the covers is this, right? It's using what we think of as configuration as code. And I love this. Why? Because the entire development environment is defined by a single file called devcontainer.json. And that's a file I can check into my GitHub repo. And I can version control it. I can share it. That means every time I make changes, let's say I added a new extension, I added a new package, I just check that in, and all my collaborators are going to get the exact same environment as me by doing nothing more than launching Codespaces, right? So this to me is super helpful. And if you look at this, what it really is there is your local operating system. So in this case, for example, I'm on a Mac, and I can actually not only run Codespace in the cloud, I can actually bring the same dev container and run it in my local environment using something like Docker Desktop. You'll see that here. I'm going to show that to you on this side. So over here, you'll see that I'm actually running this against a Docker Desktop, which is running that image. And in this version, you can see it says it's editing on dev container and it's local, whereas the other one is in the cloud, right? So this version of it is in the cloud and this one is local. So what is it doing? It's allowing my editor to connect into this container. They both share the file system. So my GitHub repo can be seen by both the editor and the container. If I make changes through the editor, they're seen in the container and vice versa. And now I have a reproducible, consistent environment I can share with my collaborators. And there's a lot of standard environments that are available to you. You can run it locally with Docker Desktop, just like I showed here. It just works. The big advantage to Docker Desktop is since you're not running in Codespaces, you can save on your quota. The disadvantage is you're not able to connect to it from everywhere. And there are some other things that are really useful for you to try. But let's kind of figure out what is the extra benefit for dev containers. It's this. This was actually a question someone asked me at the conference. They were like, you all keep doing stuff in your development environment, but it's never going to run the same in production. And one of the things that really appeals to me about dev containers is you can think of a dev container as a runtime, the first line over this, that is consistent all the way from your development to your staging to your production environments. It's the same runtime. The only difference between the dev container and a production container is the dev container is going to have a lot more tools. So you can debug stuff. You can use the editor. You can actually try out various things and check to see what is really working or not. Then optimize. You can test, for instance, then optimize it and ship it, right? But now when you do your testing, when you build your stuff, you have a much higher level of confidence that, hey, if it ran in my runtime in my dev container, it's probably going to do equally well in production. So we solved that first problem, right? The first problem was, I don't know Python. I'm not a Python expert. I'm not a data science expert. How do I just get a Jupyter notebook set up with all the environment stuff without having to do anything? GitHub Codespaces, Jupyter notebook. Great. But now we get to the second problem, which is, how do I actually learn data analysis, right? Now, or how do I learn what the thing is doing? Even if someone gave me a tutorial, how do I know what's happening? And I want to do this without losing focus. I don't want to leave. So here, the next step is install a GitHub Copilot chat extension. So one of the nice things about using dev containers is that you can actually go into an extension like this, like go into your extensions, pick something, select it, and say, add it to my dev container.json. And now it gets added into your dev container.json specification. So if you actually look at it, it tells you what extensions I currently have. And every time I decide I want to have this additional thing because it brings value, I just add it into dev container, check it in, and now all my collaborators are going to get that extension when they run this environment, which is pretty cool. So if you can use Copilot, others are going to show you what the value proposition for it is. So when you install GitHub Copilot, what exactly is it, right? GitHub Copilot is actually two separate things. First, you get a chat icon in your sidebar with a slide out chat window. So that's GitHub Copilot chat. So if I look at this, I can actually slide this out. So here's Copilot chat. And you'll see I have a slide out window over here where I can have a conversational interface to talk to GitHub Copilot, to ask it questions where it can generate things for me. And then the other one that I can do is inline, where I'm actually asking it to fix things in the code, right? So now the minute I actually added it, my dev container is rebuilt, GitHub Copilot chat is installed and activated. What does it do under the covers? Under the covers, GitHub Copilot is yet another generative AI application. So really what it is it's taking an OpenAI model that has been refined by both Microsoft and GitHub to focus on better code generation. So with this, you can do things like ask for an explanation of the code. You can ask for assistance writing the code. You can help it. You can have it simplify your code using best practices. You can have it write unit tests. You can profile. You can debug. You can do a lot of things. But the most important thing for me is I can do this in my editor without having to leave and go to the browser. So here's what I wanted to remember. I was telling you about, like, my kid is a competitive programming student. We have this problem that there are tons of, competitive programming challenges. We need to fill the gap. Let me show you what that looks like. So this is the site. Oh, let me restart this code space so it doesn't die. Let me look at what that looks like. This is USACO. This is the USA Computing Olympiad, right? We want to do this in Python. So I'm actually going to go in and say, hey, I want to do this in Python. And when I do that, you'll see that there's actually many, many fewer solutions. So we're going to say, give us something really easy to do. And then when you look at it, there's bronze, silver. Bronze is the lowest. We're going to say, give me bronze and show me something that's been solved. And look at it. There are so few problems that I can find solutions for. But let's say now I have this person, in this case, a high schooler, that wants to learn how to do competitive programming. Let's go pick one of the examples here. So I'm going to pick one of the rectangle problems because that's the one I did in the chat. These are not easy. So we're going to go look at what a problem looks like. This is what a problem looks like. Look at it. It's a lot of text. And in case you're worried, this is kind of a problem where there is a cow in a field. There are two billboards and a truck comes along and parks. And you have to figure out in a very short amount of time a function or code that tells you what's the occlusion of those billboards by that truck. And you have to do it with the best complexity in under 2 seconds. How do you do that? How does someone who doesn't know this get started? Turns out that they do have some solutions, and this is what they have. They have a slow solution and a fast solution. But I want my son to learn how to do this. I just don't want him to copy stuff. So what can we do? What we can do is we can go into this and say, hey, and I'm actually back in, right now I'm in my code spaces. So I can go into GitHub Copilot chat and say, hey, can you please create me a notebook that teaches us rectangle geometry? So to do that, I'm actually going to say, give me a new notebook. And I say, create a notebook, a Jupyter, a notebook that teaches me to code rectangle geometry in Python, right? And I can sit back and watch. And what it's doing is it's saying, okay, I see that you already have this open. I'm going to take this as context, but I don't know how that relates. I'm actually thinking that what you really want is this. And it says create the notebook. And lo and behold, if you watch this for a second, it's going to create a Jupyter notebook for me. And it's going to write the code for what it thinks I should be learning. Now, look at it from my perspective. I didn't know any of this stuff. I didn't know where to start. It gives me a place to start. And I didn't have to leave. I can stay in focus. Now, is it perfect? No, it's not. So you can actually see immediately. And in fact, it's gotten better. The very first time you saw it would have put like markdown comments, but now it's good. So you can see that it's got Python code. It's explaining. It says, hey, there's a class for rectangles. This is how you do it. I can go ahead and run this. Then I'm like, okay, this works. So now let me go and figure out what the next thing is. Oh, I need to go all the way from the top. So I'm going to define the rectangle class. Then there's no code here. There's no code here. I can go in and run this and say, okay, this has larger parameter, right? So it's teaching me how to do rectangle problems interactively. Now, look at it from the perspective of this high school student. I can give this to him and say, go ask stuff, right? But now look at this, right? It's asking me, can you provide an example of the rectangle class in Python? I can actually have him explore more. And I'll show you how we did that. So over here, we had to create a notebook. I just showed you an example of how quickly that can be done. But I want to show you what we actually did. We had the block billboard problem. So I copied that problem over into an existing Jupyter notebook. And you can actually see it here if you want to go play with the code. Right here under PyData, you will see this new notebook. And over here, you'll see that rectangle geometry problem that I talked about. We copied it over. There's the problem. We're like, okay, now we've got the problem. Can we use Copilot to start asking questions to help us understand what we should be doing? We know, so I told my son, here it is. You've got a problem. And he said, tells me I should look for time complexity. What is time complexity? Ask Copilot. We didn't leave the editor, we asked it, right? So it says, here is what it is, and here's what you need to know. We're like, this is great. All right, great. So now I didn't leave the flow, but I said, can you now explain the code to me? Because we got a solution from the site, and there was a slow solution and a fast one. Let's copy the slow solution over into the notebook and then say, can you explain this code to me? And lo and behold, it explains it. It says, here is a step-by-step explanation for what this is doing and how it's solving the problem. But wait, this is the part where I feel it's really powerful. At the end, it says, do you know what the purpose? Would you like to know what the purpose of this variable is? And so someone who really wants to learn can click on it and they cultivate curiosity, right? But now remember, this is not going off into a rabbit hole. It's actually asking questions in the context of this problem. I keep moving towards the goal of solving it. So then click it. It says, okay, here's what that does. But then I look at the solution and I realize, hey, this slow solution is not really going to help me pass this competition. Can I improve it? And yes, it says, yep, what you've got is not the optimal time complexity. I can give you order of 1. So here it is. And it gives me code. But when I compare this code to the one that's in the solution given by the students who pass the exam, I find they use classes. And I'm like, hey, can you convert this code to use a class? And it's like, here you go. So what have I actually shown in this, right? With the combination of Codespaces and notebooks, I have a reproducible environment that could jumpstart your development and learning process immediately. Then I have Copilot to help you navigate the questions you need to ask without ever leaving. So you've got focused learning. But wait, this was my moment of Zen. All of those are still very much text problems, but I can go one better. I can say, do you want to build intuition around this problem? Remember, there's a rectangle problem and a billboard problem, and there's a cow and occlusion. Do you want to like visualize it and see what it is? So we went to Copilot and says, can you just visualize those billboards for us? It wrote the code with matplotlib and gave us this visual. And immediately he's like, oh, I get it. Okay, I know now what I need to be doing to solve this problem. And this to me is where it's a really, really powerful tool. It cultivates curiosity and lets them make connections in meaningful ways while staying in the context of the problem they're solving. So that's the second part. Now the third part. Now we're getting to me. Okay, till now I was just like, if you're a learner, it can help you. But I also have a day job. And like I told you, I have lots of opportunities where I need to learn data visualization. Here's the problem. I know what I want to visualize, but I don't necessarily know what the right libraries are or the right tools and the methods are. So let's think about traditional visualization. Grab a data set. I grabbed a couple of them from Kaggle. On the left, some of you may love soccer and the European Premier League. I'm an Indian, that's the Indian Premier League. That's a cricket data set. For those of you who are not into cricket, there's a TED Talks data set that you can try out. But I'm going to walk through the cricket data set, right? So here I am. I've gotten myself a data set. I need to know how to visualize it. I need to know how to analyze it. I don't even know how to start doing exploratory data analysis on this. How do I start with this environment that I've set up? So once I get this data set, what I'm really going to go and do is say, hey, Python experts, what should I be using? They're like, go look at Seaborn. Go learn Seaborn. You need to look at Seaborn. I'm like, great. Come to Copilot and say, can you build me a notebook that teaches me how to use Seaborn to visualize this data? And by the way, here's the data file that I want you to look at as the sample. And lo and behold, it writes me a notebook, just the way we did before, where over here, you can actually see the one it created. Here is the notebook. And now I don't have to figure out what I need to ask. I can look at the code and then try to get an intuition for how to set things up. So I'm like, okay, I need to load this. That's pandas. I've got a data frame. Then I've got this table, right? So now I'm able to get really productive. Remember, my goal always is keep moving closer and closer to the final goal of I need those visualizations. So first thing, can I have it teach me to visualize it? Yep, Copilot will do that. But next, can I have it fix mistakes? So if you look at the code in this, right, this to me was actually super fascinating. It understood that cricket had a game that consisted of runs. And so even without looking at the data set, it's like, okay, it's a cricket data set. One of the things you could do is you could visualize runs, right? If that column existed, there is no such column. So when I actually try to run this cell, it says that column doesn't exist in the data set. It does. It's just called high scores, right? Because there's no semantic information that it knows yet. So I went into the Copilot inline and said, can you just fix this and use high scores for runs? Lo and behold, I have my visualization. Again, I'm moving towards my goal as fast as I can. And while I do it, I keep improving my own understanding of how to use these libraries, the methods to use, and the kinds of functions and visualization practices that will give me what I want. But wait, I can go further, right? Can I have it visualize something specific? Yes, I can. Remember that in the first case, it just wrote me a notebook, but I can come here and say, I know that there are these venues, there's stadiums. I want to see how they reflect. And as an Indian, my hometown is Bangalore. So I'm looking at it going, I bet they're the best. They were not. But I can actually go and say, can you visualize this? And now not only do I get the visualization so I can quickly get results, I can look at it and say, okay, when I want to do this kind of visualization, it's a box plot. So I need to understand how to do that. So that is kind of getting us to the point where we're like, okay, we know how to visualize data. And that's a traditional thing. It's just a sample of what you can do. And obviously, there's lots more things you can play with. But now I want to get you to the last part, which is actually one of my favorites. This comes from Microsoft Research. So remember, we were talking about it all this time and saying, okay, I got my environment set up really quickly, Codespaces. Someone told me notebooks, and yep, notebooks work for me because I can write down what I'm doing and I can write down the code, run it, understand it, fix it, do whatever I'm doing. Copilot helps me stay focused. But what are the things I don't even know? I don't know. Like as a data scientist, we all have intuition. We're like, exploratory data analysis, you need to go look at this distribution. You need to look at this kind of plot. I don't know any of this. How do I start? Microsoft Lida is a research project and an open source project that I hugely advocate you all go check out. Shout out to Victor Debia. He's the principal staff researcher who's the creator of this library. And you can go find it at ak.ms/lida/GitHub, or you can go to ak.ms/lida/org to see an organization where we're actually beginning to put together templates and reusable things and just apps and stuff to play with Lida. And we'd love to see the community contribute. So you can check that out. But let's talk about what Lida is. So what Lida does is it uses generative AI and large language models to help generate data visualizations for you, given a data set. So you literally go to Lida with your data set and say, I don't even know what I should be doing. Please help me, right? So in this case, the example that's in the research paper uses this cars.csv data set, and we're going to go look at the IPL one. But really, you think of it as kind of like this four-part thing. The first one is a summarizer. What it does is it looks at the data set and it builds a shape of the data. It kind of understands what are the fields in it, what are the types of data, what does it mean, right? Like what am I representing here? And once it has this mental model, the summary of the data, it can then build on top of it. The goal explorer is the one that allows Lida to give you a set of goals. It says, oh, you don't even know what you can find out with this data? here are some suggestions for what you can look for. And the visualization generator builds on top of the goal. It says, for a given goal, here are 3 different ways in which you can visualize it to get the kind of insight you want. Last but not least, the infograph is the only one that I'm not able to show you or run because that requires a GPU and I don't have one in Codespaces. But if you have a local device which has an NVIDIA GPU, you should be able to use Docker and set it up and try it out. If you do, let me know. But let's go see what Leader can do for you. First and foremost, Leader requires an OpenAI key. So if you actually look at it, it works with a number of different LLMs. It'll work with OpenAI, Azure OpenAI, Palm, Cohere, Hugging Face. You can go to the original site to see all the ways you can set those up. It'll also work with different visualization libraries, whether you like Matplotlib or Seaborn or Altair or D3. I haven't even used half of these. But let's go with OpenAI. And now gets me to the first point of where GitHub Codespaces brought me an additional piece of value. Because I want to set this OpenAI key, right? But I don't want this to be in clear text. And what a lot of notebooks will do is they'll be like, here's a variable, just set it in there. No, because I'm going to check this in. And now that's in clear text. And that's a really bad thing. How do I make sure that I'm keeping it secret? Now, if you're using GitHub Codespaces, you actually have a really nifty thing you can do. So under Codespaces, if you go into your settings, I think I had it open somewhere here. Was it this one? Yeah. If you go into your settings at the top, you'll see that there are Codespaces secrets. And you'll see that I actually have an OpenAI key set up here. You'll never see it again. I've set it up once, but I can associate it with as many of my repos as I want to. And by doing this, I'm effectively making that key available as an environment variable the minute you launch Codespaces with no other effort from anyone. And this makes it super useful for me. So right now, when I give you this workshop, for instance, I'll be like, just go and set your OpenAI key in your Codespaces settings and associate it with my repo, and you should be able to use your key to run the stuff. I never kind of exposed any of my secrets. Now, that won't work with Docker Desktop, but if you want to work with Docker Desktop, you can do what we always do, which is set up an environment variable and use something like .env to access it in Docker, and it works just fine. Either way, the most important thing is don't leak those secrets. Now you've got this OpenAI key. Let's talk about what Leader does. So the very first thing, I take the data set for the IPL, I give it to it and say, hey, Leader, here is this data set. Can you please summarize it? And you can see over here that it basically tries to find the shape of the data. It tells me, okay, I figured out that you have these columns, you have these field names, there's a data set description, how many records do you have, etc. And right now it has this model, right? At this point, it's able to start doing things with it. So the first thing I want to do is say, hey, give me some goals. I want to do exploratory data analysis. I don't even know what I can get with this. Please tell me what it is that I can visualize from this. And here, if I set this, you can see that it's actually giving me parameters, right? I can say, give me 10 goals, and I've got a configuration for this model, right? So over here, the pandas code is literally just visualizing it. But under the covers, if you look at it, it's given me 10 goals. It's like, okay, here are the things you can find from the data. What's the distribution of the first innings? What's the distribution of the seconds? What's the average margin of victory? Half of these are questions that I may not even have thought of. But not only does it tell me the question, it tells me what the appropriate visualization is to make sure I get insights from it. Oh, if you're asking this question, the best visualization is a histogram or a bar chart, etc. And the rationale explains it. So this goes back to my thing of, I want to learn. I just don't want to keep doing stuff, but I want this to actively teach me stuff. But now I can go one step further. I can add a persona. So I can go in here and say, hey, by the way, Mumbai is one of the teams that stands for one of the cities. So I can go in and say, we had a generic persona, but we got to change this. I want you to generate goals with the context that I am a person who's a huge fan of the Mumbai team. And lo and behold, it changes the goals now to focus on the performance of the Mumbai team. How did they do in this, right? So the fact that I can just, through natural language, tailor the kinds of goals I get is amazing. But now I can also have it visualize it, right? So once I've got the summary and I've got a set of goals, I can give it a goal and say, just go ahead and visualize it. So on the left side, you're just saying, here is the default visualization. I'm just saying, please visualize something for this goal for me. Give me anything. I really don't care. Tell me what I can do. So it shows me a visualization. But I can go back and say, no, I actually wanted to use a particular library. Can you show me again? And it does that, right? But I can also use open-ended user query. So over here, I can basically say, the goals you gave me were great, but as I started looking at them, I had another question. I'm just going to ask that to you, and it will give me the visualization of that too, right? So remember, I can potentially do this with Copilot because I can give the data to Copilot, as we saw, and say, can you visualize this for me? But what I can do here is with Copilot, I don't necessarily get to tune the parameters, right? I only get to engineer the prompt to some extent. Here I can go under the covers and tune the parameter. I can say, I actually want you to use that library. I want you to use this temperature. I can even pick the model that I want to use. So it's kind of a little bit more powerful in how we want to do this. But wait, the other thing I can do is I can actually have flexibility in kind of doing trial and error experiments. So again, going back to the learning process, now I can tailor stuff. So here I'm saying in the user query, not only am I asking what I want, but I'm giving it instructions on how, change the colors, make sure that the legend is visible, put it vertical, etc., and it'll render that. So what this does is it's really powerful because it takes away the fear that I need to know everything about everything and lets me focus through natural language on getting the task executed at hand. But what else can it do? There is also something called an explainer. So what you can do is you can go to Nitya and say, can you explain this chart that you do? Like, explain it to me. And you'll see that it gives three things. It says accessibility, transformation, and visualization. And you might be like, what on earth is that? And here's yet another thing. Nitya is an open source library. So I can actually go into the code and say, where is it getting this from and what is it? And lo and behold, if you look on the right side, you'll see it's just a prompt. It's set up a system prompt that says, you're a helpful assistant. You're highly skilled. Please explain the code in 3 dimensions. Accessibility is the physical appearance of the chart. Transformation is any kind of data transformation I did. And visualization is a step-by-step description of the code that creates that visualization. But now look at the beauty of this. Since I know where this code is, I can go in and tune that system prompt. I can add yet another dimension of something I want explained in the code. Or I can change what the default explanation is, rebuild it, and I will have a customized model that I can use, right? So this is, to me, a really powerful thing. And now, remember, all this time we're thinking about goal. So you gave me 10 goals. I customized it with persona. I'm doing user queries. I've gotten a whole bunch of goals. If I don't say anything and say visualize, it's going to give me a visualization. But I can also say, can you give me 3 or 4 different visualizations for the same data? Maybe I'll figure out the one that gives me the right insight. And here you go, right? So now we're able to build our intuition for that data without having been an expert on any of those libraries or on the data science kind of like best practices to get it done. So hopefully I took you on a really, really good journey of where you can go as somebody who's new to this space and solve those 4 problems, right? But where do we go from here? This is actually hilarious because the night before my conference, I remembered that there was this Visual Studio Code extension. That is amazing. And I forgot all about it. So this is the beauty of the GitHub Codespaces. There's this new extension. I just go into GitHub Codespaces and say, hey, can you add this extension? And lo and behold, you'll see, I think I actually have it in here. Yeah, there it is. Add it, rebuild it, and now I have the extension. But look, once I load the extension and I run this code, it then gives me a button that says, would you like to launch Data Wrangler on this data set? And I can click that right here, and it launches Data Wrangler. And Data Wrangler is a Visual Studio Code extension that I haven't even played with, but I hope there'll be future episodes where someone goes through it, which really is a visual look into the data where you can go do all the data cleaning you want interactively, and it will help write the pandas and Python code to map that into code that will do that for you. So how does that work? You can look at it and see, once you install it, it's code-centric cleaning tool. There's an operation panel, summary panel, history, quick insights, data grid, and a code preview. And so you can actually go open Data Wrangler, get a visual kind of data frame that looks into your data, go interactively try to do the things you want to clean it. It gives you insights into how many data points do you have, how kind of representative is the data set, etc. Ask it to write the code, commit it, and now it's written the code for you. Now, this is, again, part of the story where I didn't need to be an expert. I had tools help me do some of these things that data scientists know how to do, but an app developer doesn't. And so when I apply this to my data set in the IPL, I'm able to go in and see those insights at the top. I'm able to go in and write code or have it like generate some of the code for me. And this is something I hope to play with more and maybe showcase at a different time. And I think we're kind of coming to the end of this talk. But before I stop, part of the thing for me was to start seeing all this generative AI work that we're seeing, Copilot, OpenAI endpoints, Hugging Face models, whatever you're looking at, this whole big realm of generative AI, everyone is getting into it. But at the core, it's really about things like prompt engineering, and we all need to be aware of it. So I want to make you aware of this course that we just released from Microsoft. It's called the Generative AI for Beginners. So you can, I think that barcode works, but if not, it's ak.ms/genai-beginners. And I'm saying this for two reasons. One, it goes from core concepts for generative AI to actually giving you multiple application examples that are open source that you can play with to get a sense of how do you build a low-code app, how do you build a chat app, how do you build a search app. And all of them have notebooks that run in a Codespaces environment. So kind of going along with the lesson we were talking about, that's where you can do. So last but not least, these are the two resources. If you're interested in this stuff, please follow along. I have another repo here. It's called ak.ms/pydata for JS devs. That's where my journey started. I was like, how does a JavaScript dev get skilled up on all this stuff? There's a ton of learning resources that I hope to explore. So if you're interested in this, watch the repo, or like it, or just fork it and keep an eye on it. For instance, did you know there's actually a Pandas AI package that someone's working on? So I think there's a lot of work going on in the space that's worth keeping an eye on. And then on the other side, if you like what the kind of data visualization with Project Lida is, please go follow that org, like the repo, and check out what projects we have there. We have a Codespaces template that you can use to build your own Lida-based notebooks. And Victor's got a Streamlit app that shows you kind of a really quick and dirty application interface where you can tune these parameters and see a notebook that reflects them interactively. And yep, that kind of brings me to the end of it. I don't even know if I'm okay. I think I'm good, but I hope I made it on time. I started with a very simple goal.
It's okay. Very interesting session, Nitya. It was nice to see also. I did not know about that competition you have in the USA where students can need to work on these kind of solutions.
It's actually really an international one. There are ones in every country.
Okay, well, never heard about it, so I'm gonna look into it.
Awesome, and please do contribute back. We need Python examples for them.
Okay, I'll have a look in it. It's quite interesting, but of course also just GitHub Codespaces on itself. It's quite a nice environment to work on, especially also with the extensions that you showed. It's nicely to have it locally on your computer, but if you can take it anywhere in the cloud, that makes it, of course, much easier. And then
100%.
I liked it how you asked the Copilot to say, generate me now a notebook that helps me understand this and that. I was like, okay, never thought about that, but that's something that can really help students to learn more about how to do it.
Exactly. And I'll give you the example that USACU has a lot more examples in Java and C++. We can literally ask you to explain the Java code to us and then figure out how to write that in Python. And I think that kind of transferable learning is super important.
Yeah. Well, we'll see more and more that students will start making use of this kinds of Copilots to get their skills faster up and running than how we did it in the past.
Yes, and I think we're going to find almost every LLM now has notebooks. Tons and tons of open source repos that give you notebooks that can just quick start. So having this environment set up means you don't think twice, just launch Codespaces, start working.
Exactly. All right, Nitya, thank you very much for your time and the effort of presenting this talk. Also, next week we're going to a bit of overflow generative AI, but we're going to look a bit more to the landscape of it, from popular services to open source alternatives. So it's also going to be quite interesting. So all of you who are joining today, hope to see you next week again on the Global AI Notes. So have a good evening, a good morning, or a good afternoon. I will see you the next time. Bye-bye.
Thank you.